start main group elements. Do you know, in main group elements, two blocks are involved. One is S block and another is P block. Okay? S block elements and P block elements makes this main group elements. Today we discuss P block elements. P block elements having general electronic configuration NS2 NP1 to 6. That means after fulfilling NS, the electrons starting to enter NP from NP1 to NP6 all are consist in the P block. Okay. Here group 13 to group 18 are P block elements. Okay. Now group 13 is Boron family. Why? Because it starts with the element boron. And group 14 is known as carbon family because it starts with the element carbon, and group 15 is known as nitrogen family because it starts with the element nitrogen, and group 16 is what we all know, oxygen family, right? And group 17 is halogen group. Here is all of halogens. And group 18 is inert gas or noble gas, right? Group of inert gas and noble gases. Now firstly we discuss group 13 elements, that is boron family. Here boron, thereafter aluminium, thereafter gallium, then indium, and then thallium. How will remember this group? Up to bottom how? Actually I remember as Bal Gangadhar in Thailand. Okay, how will you remember? As your choice. Now start. Group 13 elements has general electronic configuration what? NS2 NP1. Okay. If we remove this electron, then they got plus 1 oxidation state, and after removing this 1 electron, if we remove this 2 also, then they got plus 3 oxidation state. So they can show these 2 oxidation states. Down the group we see that plus 1 oxidation state, they form compounds of plus 1 oxidation state is more stable than plus 3 oxidation state. Why? To know what is this cause, here a new term is included, that is inert pair effect. Okay. Now let's see what happened. Here NS2 NP1, right? This NS2, these 2 electrons remain inert. That means they don't undergo in the bond formation or covalent bond formation, or they have reluctance to form compounds. Okay, they remain as inert. So only this electron can take part to forming compounds, and so plus 1 becomes more stable, or they show plus 1 more than plus 3, although they show both, but this is more stable, okay, because of inert paired effect, right? Now discuss about hydrides of boron. They don't form directly hydrides, direct combination with hydrogen. They form hydrides indirect direction, indirect combination, okay, sorry. So they form nidoboron and arachno. Okay, these two types of borons, and nidoboron is BnHn plus 4, and arachnoboron is BnHn plus 6. Okay, nido, and this is arachno. This nidoboron is much more stable than arachnoboron, and nidoboron, due to stability, its melting point is high, and its arachnoboron melting point is low. Now this B2H6 is known as diboron. Okay, here we discuss about a question. This is Ba3. This is a halide of boron. So this is actually known as Lewis acid, right? Why this is acts as Lewis acid? Let's see. We know boron equals to, atomic number of boron is 5, right? 1 is 2, 2 is 2, 2p 1. Okay, now this 2s and this is of 2p of boron. Here it makes bonds with fluorine, right? sp2 bonds is formed, and after exciting it will be here. Okay, this was its ground state, and after excited state this comes here, and sp2 hybridization is formed. So here we get 3 sp2 hybridized orbital, and 1 2p orbital remains vacant, right? Fluorine bonded with this 3 sp2 orbital, and this remains vacant. Now let's see. This is 2p orbital which is remaining vacant, and there is 3 fluorine sp2 boron, right? So this vacant 2p orbital can accept electron pair, and we know which can accept electron acceptor is known as Lewis acids, right? So this is Lewis acid. NH3 having lone pair, it can donate its lone pair, and it is Lewis base. Let's with BF3, HF2P, and accept this is fluid acid. Okay. Here BBr3, BCl3 and BF3. Why this has happened? This is the strongest Lewis acid. After that this is the weakest Lewis acid. Why this is why this is happening? We all know F is most electronegative, right? If it is electronegative, most electronegative, then it will catch its electron towards it. So this is becomes more electron deficient, so it can able to take electrons more efficiently. So this will be more stable Lewis acid, but why its acidity is lower? Let's see. Here back bonding is happening. What? Now they are attracting electron towards itself, and here present their lone pair which is given to this vacant orbital. So this type of back bonding is happening, and due to this back bonding BF3 becomes lower Lewis acid. Hope this is helpful to you. Okay, we discuss later.